is the FRC Roundtable, coming to you all the way from Minnesota. Your host team 2052 Nightcrawler presents this weekly FRC gathering where FIRST robotics competition teams take cooperation off the field. Share your knowledge, give and get advice, solve a challenge, or celebrate what makes your team special. 3, 2, 1, go!
Okay, I think I did that right. Recording has been started. Looks like we have a small crowd tonight. Maybe we'll go really short, which is fine with me. I don't have a problem with having a short meeting as long as we get through all the things that we want to chat about. Welcome, everybody. So no one signed up to host a topic this week, and I sort of had to scramble and figure out what we want to chat about. And I had some interesting conversations after Isaac gave his presentation last week about CNC. I had a couple of emails. And I know that we've got 4 new teams in the state, or new or restarting teams in the state. And I thought it might be helpful to have a conversation about where you invest your money in terms of like tools, or like maybe equipment might even be a better word. I mean, I think we all know that we need a hand drill and we need Allen wrenches and things like that. But when you come up with some extra cash and you get either some sponsor money you set aside or maybe an unexpected donation, what are those things that every team should have? And then after that, what are the things that investing in can really make a difference for your team? And sometimes that difference might be mechanical. But other things might be just the educational value of having that in your shop, or maybe it's a pride thing. I mean, I don't know that anybody needs to powder coat their robot, but man, I think that really amps up the energy for teams when they have a pretty robot. So I'm really curious to get everyone's thoughts on what it takes to put together a good robot and give students a good experience. Before we start that, though, does anybody have any open topics? Because this is a not scheduled program, so if anyone has anything they want to chat about, let's do that first. Does anybody have any kind of current topics or questions? Open table, anything you want to ask about that you want to bring up? Okay, let's talk about tools. Does anybody want to throw out some things that their team has that they can't imagine building a robot without? Is a drill press one of those? Go ahead, Clay. Go right ahead.
There we go. I would say a drill press is probably one of those. We don't use our small one as often as we could, but we have a host of drills. But I'm biased in this, but I don't know that we would do as well as we did without a 3D printer or a couple of 3D printers. I mean, seems like the low-hanging fruit, but boy, you can really solve a lot of problems and create some with decent 3D printers.
Now, Clay, are you with Ultraviolet?
No myth.
Purple
still. Yeah.
Was that you guys that did your own resin wheels, or was that Ultraviolet?
Yeah.
Guys, right?
The team didn't. Nick did. Nick Allen. He's prototyping some wheels with potential marketing. He might be making and selling.
Okay.
I can't say much more than that. But we got to use his this year. They are. We did some 3D printed ones out of TPU, but they didn't last nearly as long as the cast resin ones that he made. We ran those for most of the tournaments we went to, and they are phenomenal. But and that's like higher tech. He's like casting stuff out of like super duper resin somewhere else. But having 3D printers to make, I mean, we made a ton of our timing pulleys, and like. We had some bumpers for, bumpers underneath the chassis for steering the rings into our under the bumper intake. Like, there's so many little problems that could be solved with just the right shape 3D printed thing. And I'll leave it for someone else.
Go ahead, Reese.
Yeah, so I'm going to concur on the 3D printing. This year we've had quite a few parts on our robot that we've 3D printed, such as some stuff on the intake. I believe at one point our wheels were also 3D printed as well. And we also had some stuff on the shooter too, more minor stuff though. I wouldn't say that it would be a deal breaker for us not to have a 3D printer, but it definitely gave us a lot more access in terms of what we can design, because it's a very flexible and very kind of rapid method of fabricating stuff.
I really like the one of the things that I like with 3D printing for our team is the camera mounts, because we can get the cameras right where we want them, and you can set them off whatever distance you need from whatever mounting surface you have, and you can get it at just the right angle. And I feel like that if there's ever going to be something that 100% we're going to have a 3D printed part in a robot, it's going to be a camera mount. I like the idea that a pulley butt breaks and now you can make one, and you don't have to go out and buy one. Bearing hats, we print a lot of bearing hats to keep bearings from popping out. And then specific, like year to year, I love that you can sort of whip up a guide for guiding a game piece. Like you said, under the bumper, through the intake, things like that. I feel like those types of things just get so much simpler when you can 3D print something and put the holes right where you want them and have the angles where you need them. Go ahead, Ben.
I'm just wondering what everybody's using for 3D printers, because we have had Ender, which has not always been the most reliable. We have a pretty nice MK3 Prusa, but this year we bought a bunch of A1 minis, and it's somebody that's been in 3D printing for quite a while, like I have. The A1 minis, there's just, or even any of the other bamboo printers, there's like no comparison for speed and how easy they are to use and just the quality. So I'm wondering if other people have discovered this or what everybody else is using.
Go ahead. You guys can just jump in. I don't want to call on you. Go right ahead. If there's a lag, hop in the conversation.
Reese, you go ahead. I'll go after you.
Oh, all right. Yeah. So this year we're pretty lucky in that our host school very generously gave us a grant so that we could get some Bamboo Labs printers. And I'm not particularly involved in the actual 3D printing stuff. So that's just not something that I really do. But I think the stuff that we've seen coming off of them so far has been very consistently high quality, and I think everybody has found it very easy to get into as well. Beyond that, I don't really have anything to share, though.
Last year, No Mythic bought, with some grant money, a pair of Bamboo X1 carbons, one of them with the 4-filament changer. After having been using a pair of Prusa Mark III S's that were workhorses but were weather beaten, and the Bamboo Labs printers have just changed the game. The price versus performance is wild on them, and as long as you take minimal care of them, they're like a Honda car, right? Like you just take minimum care of them, and they're just going to keep going forever. And we've probably last season we probably put 15, 20 kilograms worth of plastic through combined between the two of them.
Yeah, we're up to 3 of the carbon ones too. Love them. I don't know. It sounds like a sales pitch for them, but honestly, they're so easy and they're so good. The heated chamber is awesome if you're doing more than if you want to experiment with more than PLA. So we did a lot of TPUs. We did the TPU wheels, and then we did some of that nylon X material. It's like nylon with chunks of carbon fiber, and did some structural parts too. And one we probably pushed a little too far and snapped once, but the other stuff held up really, really well. And that nylon X stuff is a lot cheaper than the Onyx. I mean, you're probably getting, I don't know what, 75%, 80% of the strength of Onyx for a quarter of the cost. So it's pretty good. We did buy the material changer, didn't end up using, or the multi-material, haven't used it much yet. And the print dryer is awesome too. So, the filament dryer rather. Yeah.
I think a team could get by without the filament changer just fine. That's an extra like $300 or $400. We bought it too, and we just hasn't seen the sort of use that you would expect. It's great to like finish an empty spool and then automatically start on another spool, but no, we're not doing a lot of multi-material prints.
Can I just add something?
Yeah.
So on the topic of 3D printing, has anybody experimented with like carbon fiber filaments?
Yeah. We printed swerve wheel guards, like fairings, out of, and I actually don't think we printed these on our bamboo machines. One of our mentors used, might have been a Raise 3D. They used the printer at their job to print carbon fiber. I think it was nylon. It was probably nylon. And I think we only broke one of them. They were for not chewing up rings or chewing up notes. We bumped them out of the way instead of destroying them. We still destroyed some.
Yeah, I've printed carbon fiber on my Prusa, with both nylon and the PET G. The PET G works really nicely in carbon fiber. It takes care of a lot of the problems that people have with PET G. It makes it a lot stiffer. Nylon, I'm sure it's probably better if you get a bamboo enclosed printer, but if you dry the heck out of it, you have some sort of enclosure, and you're just really careful with the settings, you can get pretty good results. My understanding though with the carbon fiber is it's actually something that weakens the filament because it's like little chopped up, it's like salt versus longer strands from what I've been reading. What it really does, from what I understand, is it makes the prints crisper and it makes just easier to print the materials. I don't know if we've tried printing gears. We stripped the heck out of them, but I don't know if that was just some other problems.
So, I mean, the main advantage I've actually gotten to handle like a professional carbon fiber print at like a trade show. Actually, I should have a sample of one in my room right now, but I can't find it. But it is like ridiculously stiff, like almost unbreakable by hand. So I was given those advantages. I was just kind of curious if anybody had experimented with that sort of stuff.
I would use carbon fiber somewhere where abrasion resistance and stiffness are critical. And weight was also a concern / weird shape, right? Like if I could also make it out of aluminum, I would probably choose that versus carbon fiber nylon or carbon fiber PLA or whatever. Because if weight's not a concern, you're going to have a better time with aluminum if you've got the means to make a similar shape. But not everybody has that. I know I could talk about 3D printers all night, so perhaps we should discuss some other machines as well, other tools as well, so we don't get too hung up on them.
But one thing I was just going to add to that too is I think it's a really good tool. Like if you have great CAD skills, you can make things you couldn't normally make. But even for teams who don't have a lot of, you're getting started, there's a lot of like open source prints if you can find the files and just use them. So, if you're thinking I want to get into some advanced stuff, but we don't have quite the skills to make something that we'd make on a router. I mean, just the community out there has so many useful prints that, in my opinion, it's still worth it. So,
yep,
I'll throw that out there.
Yeah, we had at least 2 like prints on our machine from printables or thingiverse.com. I think the little guard around our main breaker is straight off the internet.
Yep, that's a good one too. All right, well, moving along. So we're running a drill press. I don't know what everybody else is doing, but we're using a stand-up 6.5 foot tall drill press that was probably manufactured in the middle to late 50s. It's one of those old school drill presses that it's variable speed if you change out the belt, but of course we always leave it on the lowest speed possible for drilling metal. It works just great, but I don't know if anyone else is using anything fancier that they said, I'd never trade this drill press for anything else. It sounds like we're sort of in agreement that a drill press is one of those things that every team should put the money into. Anybody have any comments on drill presses? I know that I think our shop that we have in the school that isn't robotics, but it's shop class shop. They have variable speed drill presses, but I've just never seen the benefit of changing the speed. I mean, if you're mostly drilling metal, then you're going to set it to probably the lowest speed and just leave it there. Maybe not. Maybe I'm wrong about that. Does anyone have any thoughts on that, or is it just kind of one of those things where you just need one?
I believe that for different types of metal, different speeds might be more optimal, like steel versus aluminum. I'm not totally sure about that, Joe, like what speed specifically you'd use.
That's true.
I was going to say it's also the size of the bit you're using. When you're using a bigger bit, you definitely want to slow down versus using a smaller bit. I think we probably could set our drill press a little faster because we're doing 3/16 probably most of the time. And so we could drill faster no matter what the material.
We've got a pretty underpowered drill press, like a Harbor Freight kind of drill press, but we also have it's a Bridgeport style. It's a Grizzly branded, like a Bridgeport style knee mill. And I reach for that, and the students reach for that for big drilling before the little drill press, just because we have the thing. It's basic, it's got a quill and it's got a quill advance. So it's basically a beefy drill press.
Okay. Any other kind of staples of the shop? I know that we have a horizontal bandsaw that's a relatively new purchase for us. We did not have a horizontal drill bandsaw until I think we bought it 2 years ago. Prior to that, we used an aluminum cutoff saw, so I think it was a 14-inch saw. Not as safe and friendly as the horizontal bandsaw. It cuts nice and square, but sort of terrifying, and something that we didn't often let students run. Either you had to be a student who had been on the team for a while and been around it a lot, or mostly the mentors ran it, and terribly loud. Not a friendly thing to be running when you have lots of people around. Anybody else using something different or something similar for metal cutoffs?
So on the Miller bots, we also have a horizontal bandsaw. I'm not sure what the manufacturer is, but I would say that that's definitely kind of a staple of our shop. I don't think we'd be able to make a robot without it. Yeah, it's definitely very easy to teach people. Cuts metal very effectively, and I'd definitely say definitely a very good addition to a shop if you don't have it.
So to those teams that do have a horizontal bandsaw and are happy with theirs, that's actually on my shopping list this week, because we have a similar distaste for our chop saw and cutting aluminum extrusion with it. It's great, but it sure is loud and scary. And what size, what type, with coolant or not, what have you found to be good for the robotics application?
The saw that Nightcrawler purchased a couple years ago is Clutch. It's from Northern. Did looking around and did kind of a review of, how many stars and all of that stuff and price versus quality. We ended up buying the Clutch that was on the rolling cart. And then probably 6 months later, I decided I wanted one for my personal shop, and I bought the benchtop version.
Okay.
Honestly, I kind of regret buying the big one for the team. I mean, we're not cutting enormously big stock. And so I kind of wish we would have the benchtop version for the team, because it would just take up less space, and it certainly is adequate for cutting everything that we would need to cut for the robot. It is nice. I mean, that you can start it, you can step back, it'll cut by itself. The benchtop one, you have to cut it with your hand. It doesn't have the head weight where it just automatically cuts and then turns itself off. So that is the nice thing about having the one that comes on a stand, is that it's got the auto shut off. You can get it set up, and then you can get away from it and just let it do its thing. And so that may be a better option for students, but it's cheaper to buy the benchtop one. It's takes up less room. So those are some considerations you might want to look at. But we've been pretty satisfied with the clutch version that came from Northern. And it does take some time. That chop saw, it's dead simple to get it square. The bandsaw is a little bit trickier because the band, it has to bend. So you got to get your guides so that you get that band perfectly vertical. And the squaring the cut this direction, the lateral horizontal direction, it's not a very big fence, so it can take a few cuts to get that set up just the way you want it to. But yeah, we've been happy with it. It was a good purchase. I'm really happy not to pull out that big scary metal chop saw anymore.
Yeah, great, thanks.
I was gonna throw in, we got by when we were on a shoestring with a vertical bandsaw for a long time. It has a ton of utility, or like outside of cutting extrusion, it can just do a ton of things if you want to try to freehand some metal plates and things. But we also got like a miter gauge for it, and if you play around with it, you can get that extrusion square-ish. I would say like within a couple degrees. Honestly,
Yeah.
if you're using the pre-drilled like Vex tubing and stuff, perfectly square is not always all that big a deal. Honestly, if you've got
Right.
1/8 inch gaps and or maybe 16th inch gaps. Yeah, we got by with that for a long time. And yeah, it's a little slower. You got to push a little bit. Standard safety stuff. You've got an open blade you're pushing towards, but worked pretty well.
Now, do you have a metal cutting bandsaw, or is it a wood speed bandsaw, the vertical one?
Yeah, we actually it's what is it? It's a DeWalt portable one, and then we bought a little table for it, so you can pop it off too and do random things. But yeah, we put a metal blade in it, and honestly leave it in for wood and everything too. Yeah, it tears out a little bit, but for what we're doing, that's usually playing field and things we don't care about. So we've done pool noodles on it, just things like that.
Wow, it gets through pool noodles.
Yeah.
I will say that Nightcrawler prior to COVID, I think Nightcrawler cut 80% of what was on a robot with a hacksaw. I really did. I mean, we would only pull out that big scary saw for like super important things like frame and elevators when you needed to have things perfect. But for most of the stuff on the robot, I feel like our build students were mostly just marking and scoring and cutting with a hacksaw and I don't know. Nightcrawler didn't do any CNCing prior to COVID either. It was so. I guess things all advanced very quickly in the last 5 years.
Didn't we have the portaband for doing some of that too?
We did have a portaband. We still do have a portaband, but I don't remember that being used a whole lot, honestly. I think anytime we were cutting 1x1 L or 1x1 tubing, I feel like it was in a vise and there was a kid hacksawing it.
I was going to mention kind of dovetailing into using the bandsaw. So it makes an okay cut, but they're usually not super square. So we have a big stand-up disc sander / belt sander with a table and a miter gauge, and that's what we usually, if we need to have a square piece, that's what we usually end up using to make the piece square.
Yeah, I will say I don't know how many other. I'm curious. Does anyone else use a sander to square up all your cutoffs? It's so
We
nice.
don't use it to square up, but since we've been using a chop saw for the last year, they are very square to begin with.
Mhm.
I think they may have used to use it.
And
We
or
also-
even if it's just like a 16th too long or something like that, you put it on that. You pull it down to your score line. Go ahead. Sorry, Reese. Go ahead.
Yeah, I was gonna say that. Yeah, we also use a sander for getting like the final kind of bit of a cut off. If it's too long or it's just not square, we often just throw it against the sander for a little bit to get it perfect.
Yeah, that's been a relatively new acquisition for us at post-COVID too, where we got a really nice belt / disc sander in our space. Where we don't actually even own it; we're borrowing it from one of the middle schools. Eliminated their wood shop, and so we have borrowed that belt sander disc sander combo since the school is no longer using it. Anyone else want to throw out anything that you kind of every startup team should consider buying or acquiring?
At least one vice.
Yeah.
Yeah.
Yep.
Gotta have a vice. Oh, I have something. So we don't weld. Our team's never. As far as I know, we've never welded. Everything's drilled and riveted. We bought the Milwaukee cordless rivet tool. Amazing. So I mean, that was just last year. So we've been hand riveting for since the beginning. But that hand rivet tool is a game changer in terms of speed and effort. No more hazing the build students by making them use a hand riveter. That's always a fun task to teach kids how to rivet, and it's kind of boring now with the power riveter. The Milwaukee power riveter is really, really great.
Yeah, that's the power river is definitely something I would, as a captain of the Norbots, we would consider like purchasing if we are able to at some point, because I have used one of those in the past and they're extremely convenient.
Yeah, I wish we would have bought one sooner, but we're very happy to have one now.
So Clay, you said you're using a miter saw, or what we're using to cut your metal. I kind of.
Oh, it's I think it's either 14 or 16 inch DeWalt chop saw.
Using
with a.
Go ahead.
Using a metal cutting saw blade on it, and that's just for cutting aluminum.
Are you using an abrasive wheel or a diamond tooth wheel?
Not diamond. It's not abrasive. It's a. I can't remember exactly what the blade is. It's like, I could probably find it. I'm pretty sure it just came from Home Depot. It's a Diablo brand probably. But this is something that a coworker of mine turned me on to when I was cutting some 80/20 for a project at my job, and he's like, "Oh, just use the chops." I was like, "What? You can't do that." It's like, just take a light cut. Clamp your stock, and it breathes its way through aluminum. It is still loud and scary, but we made, I squared the saw blade up real nice, and it makes perfect cuts. So once we had a few students, like you were saying, we trusted with the saw and got them comfortable with it, right? Like, here's some ways that you can make this less scary. And all of a sudden, our cuts are straighter, and they all happen faster because you could set a hard stop. You needed to cut four pieces to the same length. You set a hard stop and cut them all in rapid succession. Another tool for those who are still using chop saws, that we implemented this at my job for a production step that uses a chop saw, something called a soft start mechanism. And it basically is a current limiting device that, how it keeps the saw from kicking, right? When you first fire up one of those saws, it kicks back on you, but a soft start forces it to ramp up. And so it's a lot less scary to use, and probably safer for a new operator, right? Who's intimidated already and then has the saw jumping around on him. So that was, I think, $150, and it's just, you plug it into the wall and you plug the circular saw into it, and it just works. Does that answer your questions about the chop saw?
Yeah, we went for one of the we spent a bunch we had a big grant, spent a bunch, and we got one of the metal cutting saws. It was supposed to be lower RPM, higher torque, 14 inch. And I don't know, it's still as loud as heck. It's still scary, but I mean, it's it's supposed to keep the RPM's way lower, it is nicer. It's less scary. I mean, it's still not good. I mean, it's still everyone in the room, watch out here. It's going to be loud for a second here, but it breezes through anything we've thrown at it as far as aluminum, and it has a steel cutting blade. And yeah, exactly. The Evolution 1 is what we got.
Yeah, that's the one we have too, is the Evolution saw. It's, like you said, lower RPM, a little bit safer. Any other kind of staples that you feel like for construction that you feel like teams really should have? moving on to other things, I feel like there's a ton of electrical crimpers that, except for like ferrules. I think a lot of teams don't use ferrules for their stranded wires, and they're. I feel like that's kind of a good one right there, especially with everything being a push connector now on the PDHs and things. I think a lot of young teams probably aren't thinking about putting ferrules on their stranded wires, especially in places where you might be dealing with frayed wires a lot. We do soldering. We solder all of our CAN wires and use heat shrink tubing for our cans. We use Wagos in anything that's a temporary connection. So you lose. We lost a Spark Max at EMCC, and our kids were pulling out the soldering iron to fix the can. And we reminded them, hey, for just temporary fixes, just use a Wago connector. So those Wago connectors are really great for prototyping or quick fixes where you can't pull out that soldering iron. I don't know. Does anyone else have anything that they think is kind of a put in your toolbox type of deal?
Well, like, so on those CAN wires, you solder like every single one of them together. So there's no like connectors anywhere, right?
That's right. Yep.
Okay, that's interesting because like on our team we use every single connection between different like modules that have CAN wires. We use it either DuPont's or Vagos. No soldering.
Mm-hmm.
What do you think the like the advantages with that are? Obviously, more kind of stability, but.
So I will answer your question, but I will first say that Talon 2502 did a session on wiring about a year ago. It was probably actually a year ago, almost exactly to this date. And there was a very heated debate on that call about what to do with your CAN wires. And it comes down to a couple different things. For Nightcrawler, I will say that we solder the connection and heat shrink it for a couple of different reasons. One is that, we trust the solder connection. We make sure that the solder connection is good, and then we heat shrink over top of it. But there's no extra weight hanging off that wire. And so if you've got CAN wires and you've got Wagos or something else, extra connectors hanging off of that, and it rattles around in your robot, it has the potential to come loose. But we've also found that we've seen a lot of breaks in the wire because you're constantly tweaking that wire just a little bit, and it stresses it and it causes it to break. And so the consensus on that call, I believe, if I'm remembering correctly, is that if you're using Wagos or Andersons or anything like that, you want to make sure that you always securely zip tie that heavy part so that it can't swing around. So you're securing that to something. And then probably also strain reliefing your wire so that your wire's not wiggling at the point where that connector is and causing a break point. But yeah, it was a surprising part of that call. It was a very heated debate. I mean, people were respectful and everything about it, but they were like, if you're doing anything else, you're doing it wrong. That was a great talk, by the way. I mean, if there's a couple of talks, that would be on my top 5 that I would recommend going back and watching, because there was some really good advice on electrical on that call. But yeah, we didn't used to do that. We used to buy CAN connectors that you used a Wago and a little Wago screwdriver, and you would do a push terminal. And so we would have these mounts where back in the day you would have Talon SRXs or Victors. And then so we actually 3D printed a mount, so your Talon and your CAN connector mounted on these stacks of motor controllers. And so you'd put your Talon SRX and you bolt that in, and then right next to it, you'd bolt in the terminals for the CAN. And so everything would run from basically terminal to terminal. And then, and if you didn't strain relief your wires, now you have a point where they rigidly go in and the wire bounces around and then they end up breaking off. So we started doing soldering probably when we started using mostly Falcons, and then you're just making a loop with your CAN. But yeah, I tell you, there's a lot of debate, and I don't think there's a wrong way to do it. Honestly, if you can use whatever solution you want, as long as you're protecting your wires so that they're not wiggling loose and then causing a failure point in the copper.
We're trying something different this year with we are probably going to continue running 2 can loops on our robots, one for the swerve system and then one for everything else, just to keep the latency down on the swerve. And it seems obvious in hindsight, but we're going to use different colored wire for one of those loops and then the other one. Because you can make your own swerve twisted pairs, right? So we've got green and yellow that I think will continue to be our drivetrain color. And then I think we're going to do blue and yellow for the other loop, because the few times that we had to rebuild our robot or take things apart and start connecting stuff back together, I think almost every single time we'd get some kind of can error because the 2 loops had been interconnected accidentally. You make them different colors, it gets a lot harder to do that.
That is fascinating. So we're planning to run Canavar for the first time this year. I hadn't even considered 2 different colored wires for the can loops. That's a genius suggestion.
We also, I learned this from my coworker who does like combat robotics, I'm like BattleBots, not military. But he uses silicone wire and silicone insulation with high strand count, fine, like very, very floppy, very flexible, still 22 gauge wire, just like everything else. But the silicone wiring insulation is tougher, slicker, more resilient, and still twists up just fine. And with high strand count wires, they're rated for a lot more motion before they fail, right? The individual fibers can slide up against each other as they're being bent all over. And it's, at this point, that used to be a premium product, but it's everywhere now. You can buy it on Amazon. And other than the occasional issue where, you'll, in a connector that also is supposed to capture the insulation, silicone insulation is generally thicker. And so there have been a few moments where you have to sort of like whittle away at the very end of the insulation so it still fits. But those wires I have seen so far are way less prone to fatigue failure, like bending too much and then breaking. Yeah.
Is anyone making, now I'm sort of moving into more complex stuff, and maybe we'll come back to simpler things later, but is anyone for wiring making their own Molex connectors for wires to connect Raspberry Pis or your camera connections or anything like that, LEDs?
We are, as of last year, I started. That's a skill set that I brought into the team. I've been slowly teaching people to crimp and to, make the table that you want just the way you want it versus, just barely making it work. We're slowly acquiring crimpers and kits for like fixing things. I've just sort of been like, hey, anything that we have, any electronic device that we've got that's got like a pigtail coming off of it, like a Spark Max, we should be able to fix all of the wires on that. We should have spare parts and the crimping tools to fix the 6-pin JSTPH connector for the encoder that goes to a motor, like those things that break all the time.
So do you have any advice around making your own cabling that you are willing to share?
Yeah. Buy the cheap crimper, because the only thing the name brand crimper gets you is accountability to the manufacturer. Like if you're going to put something in space or on the road or in a medical device, if you crimp it with the manufacturer's crimper, they'll back up the quality of that crimp, right? But the knockoff crimper from Amazon or whatever works just as well for a robot. And something that's in the pipeline at No Mythic is a crimping and wiring workshop where I'm going to, bring in a couple of crimpers of my own and one from my office, in addition to the team's one, and a bunch of wire, and just crimp a lot, right? With some scrap wire, right? Like the thing that makes the thing with a tool like that is just muscle memory, is just doing it a lot. And you don't want the first time or even the second time or the third time using one of those tools to be in the pit at 10K with, time pressure, right? So Liam Sykes, our team captain, is also pushing hard for this. He's spearheading a lot of this. I got to give credit where it's due. He's writing a long how to electronics document for the team as a part of his sort of senior effort. The other thing, I'll give it back here in just a second. The other thing that we've been doing with small connectors, I think I mentioned this on a call before, but the JSTPH, the connector I was just talking about, that is so just excited to fail. It's just loves to break. 3M makes a product. It's a ultraviolet light curing epoxy. It dispenses with a little like a Lure-Lock syringe tip and cures with a UV flashlight. And the product that we're using is pretty flexible. It's the sort of thing that you wear gloves and you wash your hands when you're done with it. It's not good stuff, but it cures in like 10 or 15 seconds, and you essentially glue the wires into those connectors, and now all of a sudden the strain on those wires is you've linked all 6 of those tiny little weeny wires together, and so they can reinforce each other. Whereas the shortest of the wires, or the wires on the outsides, were the ones that were first to fail because they were getting tugged on the most. Mm-hmm. So we started doing that and haven't had anything like that fail anymore. And then we have connectors that the top of our Kraken motors, we've got that like a hat that sits on top of them with some like a can and power connector on the top. We've potted all those connectors and reinforced them and haven't had any failures since doing that. So I've talked enough.
Oh, that's good advice too. I hadn't considered reinforcing that like with a resin or something like that. That's a really great piece of advice.
I think it could be accomplished with hot glue as well, just fine. But yeah.
Oh yeah, hot glue. Yeah, every team needs a hot glue gun. And I will say we now own a cordless hot glue gun, and just like the cordless riveter, very nice to have if you've got a 12 volt or 18 volt glue gun. We have the Ryobi one. And we have a mix of kind of cordless tools, mostly Milwaukee and Ryobi, but that Ryobi hot glue gun gets used a lot at competition, probably too much in many regards. But yeah, that's a really good one as well.
Yeah, I was gonna say there's a hot glue gun too. I just like that runs off the DeWalt batteries too. So if you have your standard batteries, it was like, man, I want to say it was $30, and we had it for 3 years now, and it just runs like nothing. I mean, I suppose hot glue is a solved problem, but there's not much more hot tube. But yeah,
hot glue, man.
I just picked up a tool this year. Oh, I'm sorry. Go ahead.
No, what's like the benefits of using like hot glue and stuff? Because like I know my team doesn't do it, and I don't think you really want to do it. Use like hot glue, and I just want to know like what it's used for. Sorry.
Go ahead.
Yeah.
Somebody else take it.
So in our team, hold on. So in our team, at least, hot glue we usually use hot glue for kind of securing connectors in place. Especially, I think the place we use it the most is securing the connectors for motor encoders to Spark Maxes, because they apparently flop out a lot. Other than that, I don't know what we really use it for. Mainly just holding stuff in place.
Anybody else?
We've used it as a patch fix when something breaks, but mostly we're doing what Reese does. We're taking the strain off of the wiring whenever we can. If a zip tie won't do it, hot glue might do it. Where the RJ45 or where the Ethernet connector goes into the top of a Limelight, which is, I mean, I feel like we put an entire stick of glue on one of those things just to keep it from wiggling. There you go. Dr. B's got it.
Yeah. Those Ethernet cables tend to have a little tabby thing break off. Gluing it, basically any sensor wire that runs into our RoboRio gets hot wired. So if you've got a limit switch or a beam break switch or anything like that runs into your DIO, into your RoboRio, all of that gets glued. Our radio all the connections on our radio get glued. It's mostly for keeping wires from popping off, I would say, for pretty much all teams that are using hot glue.
I gotta say too,
Yeah,
like,
it
oh, go ahead. Sorry.
Yeah, I was just gonna say, if you feel bad about using hot glue, just keep in mind that pretty much every consumer product uses a little bit of hot glue in there.
I work in manufacturing, and we use quite a bit of it in like digital products, like handheld, high tech stuff.
I was just gonna say too, if you're a team who hasn't used it in the past, like the robots have gotten faster and they hit harder, and so like I think we got by probably my early years of mentoring more or less without it, and then probably especially when Swerve got hot and full field sprints and things, it's just like it just became a requirement. Robots are hitting each other harder, and all the energy goes into your wires. So yeah.
Would it be like a good idea to start like hot gluing like wires then? Because I know like my mentors are kind of against it, so I don't know.
I would say that start with it as a fix when a wire pops out, right? If you're running the robot and you're seeing a wire popping off, start there. I don't think you should, maybe, especially if this is something that's sort of against your culture, I don't think you should go in and start slathering hot glue on everything. But I do think that over the years, your mentors or your captains have probably seen situations where, man, we have such a hard time with the radio pops, we seem to lose our PoE connector or our other Ethernet cable, or the limelight. Maybe you've got a cable that tends to pop out of the limelight. Depending on when your limelight is too, that the little Wago connection for the power that go into those limelights, I mean, that can also be a place where if that limelight's up high or if it's on something that moves, hot gluing the power connection in for a limelight can be helpful. I mean, you have to deal with the fact that if you have to replace something, you got to get all that glue off. That is a very adequate and valid argument against hot glue. So you have to kind of weigh the benefits against the trade-offs.
It's not so hard though, because honestly, we've had a Navex pop off, and if you glue it down, it will not pop off. If you don't glue it down in the middle of your match, it's a problem.
But the Navexes have screws, right? You could screw it down.
Yeah, it just screws down, but actually the screws are on the opposite side from where the connector is. So
oh yeah, that's true.
So honestly, we've
true.
had the Navex still screw down and pop off. So hot glue is your friend.
Yep. Yeah, I mean, that, like Sam said, just the contact is just so much more contact. So things just tend to pop out. So anything that can or has popped out, it's a good candidate for some hot glue.
And while we're on it, honestly, it's probably a little outside of this, but like we saw 2056, they released their tech like documents, and they've been 3D printing all of these strain relievers for all of their electronics. So like anywhere a wire goes in, they have this little 3D printed place where you can zip them down. And they haven't released those, so like that's something like some of our design students are working on, is like mimicking a lot of that, because like I don't know, but we had a front row seat when them in 254 got knocked out in Worlds in 2023 from losing wires, and looked like not fun to lose your whole season on that. And so I don't know, it seems like something worth looking into anyway.
On our team, we have these little. Plastic kind of adhesive pads, and you just kind of put a zip tie through them, and you can zip tie your wires down. That's what we use for kind of strain relief times, and also just securing stuff in place too. Yeah,
it's good for routing, right? When you're routing your wires, those little zip tie pads are great.
Yeah, we've used them for also just securing the whole spark max in place too, so it doesn't just wiggle around and go places you don't want it.
I'm moving into some like advanced manufacturing. I know that Nightcrawler bought a CNC post-COVID, and so we have a CNC router. It has a spindle, not a router, but it's a flatbed. It's the Amio X8, which is a very popular CNC on Chief Delphi. It's one of the reasons why we chose it, based on the teams on Chief Delphi that were talking about it. And you can buy it from West Coast Products. We bought ours direct from China and had it shipped from China. And I actually only took a couple of weeks to get here as well. Very affordable. I can't remember what we paid for it, but it was like $1,000 or $2,000. It was It was a very affordable machine, and with a spindle, it's a water-cooled spindle. It can go through just about anything aluminum that we throw at it, and polycarb as well.
So Scott, it's actually 2,800 right now, and it's over 500 to ship.
Oh, okay.
And
So
that's from Omeo. West Coast
Okay.
is over 4,000.
Oh, wow. That's significantly more than what, because maybe we paid less than close to $3,000, but that seems like more than what we paid. But again, it was, pre-tariffs, pre-COVID, or well, maybe it was just after COVID. But anyway, we're running the X8. Isaac, who gave the talk last week, has really done an excellent job of tuning feeds and speeds and coming up with pathing and fusion, and is really pushing that machine to its limits. And it's done very well for us. I have an old Shapeoko in my workshop that I used before the team bought one. It's got a router. It's got belt driven. It doesn't have lead screws, and it did everything we need to do. It just did it slow, but it's a nice machine. Cuts aluminum and polycarb too, but definitely you're going to be investing some time outside of a meeting to run that thing. Anybody else have any experience with CNC routers?
Yeah. Mythic has an X-Carve Pro. It's a 4-foot by 4-foot. It's got a spindle as well. And I think that the Y is a ball screw and the X is either ball screw or a pair of rack and pinion, maybe. It's like almost more machine than we need. It's a lot of surface area. We probably would have been fine with a 4x2. But it comes with a piece of software that I'm torn on because it's too easy to use and it locks you out of some of the features that like a Fusion 360 CAM package would give you, but it makes it really, really easy to take a simple flat like a DXF or an SVG file and cut it, and it has a bunch of presets baked in. So it is a tool that makes it very easy for a relatively inexperienced machinist to pick up and make stuff with. If you're fine with plus or minus 5 thou, which we are mostly, it's great. And that software is called Easel, I think.
So
it
Clay,
might work with other machines too.
So Clay, is that the only, you have to use that software with the X-Carve? You're not allowed to use anything else?
I actually just at the end of last year started using, what is it called? The answer is no, you're not bound to it. You've got to do a little bit of messing around to, you've got to set up your preambles and your I'm trying to remember the name of it.
Is it Universal G-Code Sender?
It is. Thank you. That's exactly what it is. So Universal G-Code Sender with a little bit of tweaking to get everything lined up, and all of a sudden you can run the machine faster. You can do 3-dimensional rather than 2.5D machining with it, and you can change your. I think that the software that comes with it turns arcs to line segments, and so you get sort of a faceted curve instead of a nice smooth curve, interpolated curve. And Universal G-Code Sender lets you do that. That was that's a big step up in complexity, learning that and also learning the machining in Fusion. And so we have a smaller group of students who, maybe only 1 or 2 at this point this year, who can use Fusion to do machining or to create toolpaths. But for most stuff, we can use the baked in stuff. This the software that came with it. Sorry, Easel.
Clay, I have an X-Carve, and actually you can use G-code developed from Fusion right in Easel. There's a way to import it.
Really? I would love to hear more about that.
I don't know exactly how to do it, but you can. So you have to set up a preprocessor or a post-processor in Fusion, and then you can put that code. You just load the tap or NC, whatever file comes out, and you can pull it into Easel and use it right there.
That is the coolest thing I've learned today. Thank you.
I have a Shapeoko, and Shapeoko comes with an out-of-the-box software that's really simple. Brand new CNC people. You just, like you said, drop in a DXF and you set your depth, or you can import a step file and set your box boundaries and things like that in the step file. But you can also create a post processor in Fusion, export that NC code, and then you can just load up the NC code, and then the software that comes with the Shapeoko is basically just starting and stopping the job, and it's not doing anything else. So I like that part of Shapeoko, and in fact, I've recommended Shapeoko to another robotics team who they admitted and they knew that they were not going to have time to learn Fusion, and if it was anything as complicated as Fusion 360, it wasn't going to do them any good. And so I like the idea of these CNCs that deliver kind of a easy mode for cutting stuff, and then but you have the option to use more complicated things and kind of push your machine to the limits. The Amio is, I don't think is that. We use, is it Mach 3? Is that what it has been?
Yeah, it's Mach 3, and it's pretty long in the tooth because I think they're on Mach 4. I don't think they've updated it for 12 years. It has definite quirks that you have to learn to use. It's really powerful, but there's much more modern software that you could use. We could use other software, but it would involve us having to run all the calibration of the machine, basically figuring out how many steps per millimeter or per inch that each thing travels, which directions, all the frequency and all that stuff that's already set in, that they've already set up for us.
Anybody using anything fancier, water jet, or maybe even simpler, like laser? If you're using laser to do any type of prototyping material, we will sometimes use the school's laser. The team doesn't own one, but sometimes we'll go in and we'll use a laser to either do cardboard if we're just getting a dimension, or small plywood if we're trying to get something where we could actually throw a ring in it. Anybody have anything else they're using for cutting material?
Yeah, we've actually got a Falcon 2, which one of our printers won in some contest, which is really cool. It's got a 40-watt laser, which is crazy. And doing either thin plywood or some kind of cardboard is no time whatsoever. You just divine your paths, you hit the button, it does it. That's been really cool. So at the end of last season, we got that. So being able to do our hooks or some other things to figure out, does this geometry work in cardboard was really cool. Unfortunately, it's in my garage, not in the shop, because it makes a lot of smoke and we don't have a lot of space for doing this stuff. But even a cheap laser is pretty good. That's like a $1,600 machine. It's not super expensive, but the Falcon 2 is super cool. And you can cut out your numbers for your bumpers. You can cut out wood for the prototypes. It'll cut anything up to like 3/4 inch plywood if you're willing to deal with a bunch of smoke. So it's a cool machine. It's not super easy to use, but honestly, it's pretty cool. And we figured out how to do prototypes, do things for the team. We're making stickers for our cars. It's actually very cool to use, and it's not super expensive, which it surprises me that it's a cheap laser that can do a lot of stuff.
So I have access to a laser cutter through a local makerspace, and I recently got training on it. And my first impressions on it was that it was like shockingly easy to use with the software they gave us. Your basic workflow for is you basically prepare your whatever you want to laser cut as. Either, I believe DXF works, you can use SVGs or even PDFs. You then import it into software. You get kind of like a Adobe Illustrator kind of like UI, and then you configure stuff, and you literally just send it off to the laser cutter, and it will cut it. Yep. Oh yeah. Was that? Yeah, it's laser cut. This is
just playing around.
Yeah, this is what I cut for the class. Yeah. I think the hardest part is going to be dialing in the laser so that you get the results you want. But I mean, with a little bit of trial and error and experimentation, it really shouldn't be that hard. So I would overall recommend getting into that if possible.
And to be clear, when we say the Falcon, we're talking about the Creality, the one Falcon from Creality. Okay.
Yep, for sure.
A couple of years ago, No Mythic got a grant for a Glowforge Pro, and that has seen a lot of use. And they'll sell you a material that's got QR codes on it, so you put a piece of stock into it, it knows exactly what it's cutting and how to do it right. It became very, very turnkey, and it came with a filter, or it came with a cabinet that sat on the floor with some flex duct that runs up to the thing, and I mean, it smells like someone in the room has been sitting around a campfire, so it's not terrible. There's like the smell of a combustion, but it's not as bad as it would otherwise be. And you might one of our students made something like 500 of these little medallions last year and was giving them away at the tournaments, and that machine was running for weeks and weeks and weeks.
Now, is the Glow? I think I have a friend who has a Glowforge. Does that machine require a subscription to run? Like, it only works if you're connected to the internet?
I don't think so.
Okay.
I think that you do publish to it. You post to it over an internet connection.
Okay.
Like, it might be like Bamboo Studio, where it does go up to their server and then back down to your machine. I know we don't have a subscription for it, though.
I may not have the right manufacturer. I know I have a friend who ended up who bought a laser for his hobby that he was doing, and he shared with me that he loved the machine. It did beautiful work. It was awesome, but he was frustrated that you needed to have a subscription to keep it. You own the hardware, but you couldn't use it unless you had a subscription, and you had to have an active internet connection. So I wasn't sure. I thought it was a Glowforge, but I could be wrong about that. It's something to think about if you're listening to this
I may be wrong.
On YouTube. Check that. If you're buying hardware, make sure that it's going to work for you without a subscription, I suppose. Anybody running something fancy like a water jet? I don't know that I think I have heard of teams who have them as part of a shop class at school, and so they have access to them. But I don't know that I've ever run into a team who actually owns one as the team.
Last year, we have a mentor / alum who is in grad school at the University of Minnesota Twin Cities, and they, in the mechanical engineering department, got a very large water jet cutter, and we cut a bunch of pieces, like our hooks for our climbers, and then the side panels for our elevating shooter are 1/4-inch aluminum, very, very, very overbuilt, but never broke. And that was a great resource to have, and it didn't end up costing the team anything either. So any other teams in the Metro, I would reach out to that, utilize that connection. They were pretty generous with it.
That's good advice. One of the things that I've always been jealous of, and I think a lot of our students share this jealousy, we go to events and we see people with black and bright green robots. And I'm curious to know what those of you who have robots that are not aluminum colored robots, how are you doing that? What are you using? Are you using a paint booth? Are you a powder coating? Are you doing a combination of both? Anodizing? Teach us. Is that paint?
No, you need to use
vinyl.
Super
nice.
super duper easy. Honestly, we covered our whole robot on vinyl. It was super easy, and it didn't fall off. The worst thing that can happen is you get a frayed edge. No big deal. But honestly, we covered our lift, our hooks, a bunch of other stuff with vinyl from like Home Depot or some other place. You order it from Amazon.
Sure.
Easy peasy. And actually, we're going to cover all of our laptops because it's so easy just to make them all green. Just have to find the color of your team and go for it.
That's good advice. I remember seeing that now. And you guys also had corrugated plastic to sort of cover up places where you didn't want main pieces to fall inside.
The Coroplast is super easy. You just cut it. Either draw the lines where you're going to do a fold, like you're doing a metal model on aluminum.
Sure.
And, cut it with the scissors and make that your sponsor board or whatever.
Sure.
Coroplast super light. Put it on the robot, and it's super durable. But yeah, we've decided we're going to use plastic and vinyl as our major color things. Works really well. I've looked at powder coating. I've looked at all these other things. Anodizing aluminum, expensive and difficult, and the part breaks and you do it again. The vinyl is super easy, and if you don't have time to do it, no big deal. It's really, really super easy.
It's a really great piece of advice. I know that I think CIS. I think one of the coaches on CIS told me that they bought a powder coating booth last year, 2 years ago, and I didn't look into it, but he said honestly, if you ever want to do it, the price is not cost prohibitive because it's basically a gigantic electric oven, and so you just plug it into it. I think it's a 30 amp 220 outlet, which is what an oven is. So if you have any place that has a welder plug or an oven plug, you can just plug it into that. And I think he said they got their powder coating done from Harbor Freight, and so. But I think the biggest problem with either a paint booth or powder coating is just the time, because now you've just lost a day or maybe 2 days because you got to get all your parts in a booth, get them all sprayed, let them cure, bake, dry, whatever it is. That's probably the biggest problem I see is that now if you're a team that's building 2 robots and you're building a second robot, okay, that makes total sense. But I feel like a team that's building a robot and they want to get that piece cut on the CNC and immediately put on the robot, taking time to powder coat or paint. I don't know.
So this is vinyl stuck on polycarbonate. You just cut it out on. Good. You either cut it on a laser, or if you got a Cricut, and then stick it on there. Super easy. This is our coolest thing, and our graphics department was excited to have that on the field. But it took us like 30 minutes. No big deal. Yep.
It's a great idea. It's really great. And it looks awesome. Your robot was easy to identify last year.
It's gorgeous.
It looked great.
It's hard to miss the bright green robot, actually. we're very green.
We're very purple, and we are fortunate enough we've got a long time in-kind sponsorship from Twin Cities Plating, and they basically they keep a tank of purple for us. It's not a big one, right? We're not doing stock in it, like long stock, but I think we could fit. I think it's 3 feet deep with a purple dye. But they'll do black. They keep black in stock all the time for their other clients. But I wasn't there when this relationship was forged. But the owner of this company is like all in. He's like, oh yeah, just send it to me whenever. If I can get it, I'll do it as fast as I can. And we are a team that does 2 robots. So our practice bot versus our comp bot. Our practice bot is silver, and our comp bot is purple and black. And I would say, being a team that competes at Duluth when we can, first week, and having to build 2 robots and have one of them sent out for plating. We also have a sponsor. Our school is in an industrial district, and next door we have a sheet metal fabricator and a CNC manufacturer. So they do some of our more complicated sheet metal parts. So the turnaround of like getting stuff, sending stuff to them, getting prints, sending it to them, and then turning that around and sending it off to the plater. Both are in town, but both have reasonable lead times because they have actual business. It creates a tight schedule for getting CAD done, and perhaps prohibitively tight, in my opinion.
Hobby Lobby.
You got my gears turning on the vinyl. At least for we've had some students be very disappointed when a part is not done in time to get plated. Or anodized, and I've been like, well, we could spray paint it, or we could rattle can it, or we could, get some big purple Sharpies or something like that. But
it takes 5 minutes and a sharp, like a sharp knife, and you're done.
I love it.
I have also thought about in the past of just if we were to buy a powder coating oven, of just powder coating all of our stock. Like we buy our stock, we cut it in 6 foot lengths or whatever, and we do it, and all of our stock is pre-colored. But again, how much of this is a benefit to the students and part of that whole culture and appeal, and how much of it is just taking away from being productive. I think it's a balance. I think it would be fun. We've never had a robot. We've never had a robot that was. We've had some parts that were spray painted. We've had some parts that were anodized, but we've never had that be kind of the whole robot or core to the robot.
Has anybody ever tried like spray painting metal and then like putting it in a laser cutter to etch the paint off?
Mm.
No. But you could stencil. Right? You could laser a vinyl decal or a negative decal or something like that, and then spray paint and then remove the decal.
Yeah, that's kind of what I was thinking. Interesting.
Yeah. Hey, there you go.
Wow. Okay.
Now, is that spray painted? You cut with vinyl to do a negative, or is that vinyl there?
We did a mask and then spray painted
Okay.
and then lasered off the edges because they were crap, and then it looks awesome. Yep.
Neat.
Yeah, I've got a vinyl cutter. It's not a Cricut, but it's a vinyl cutter, and I've used the vinyl cutter to do some very kind of advanced type of masking off for paint, but not for robotics. But I can say from experience, this works really well. I enjoy my vinyl cutter too, but we've just never done that to cover the whole robot. So something fun.
The last few years we've done our sponsor panel. We have a parent in our community that's got a Cricut that just, we give them our sponsor SVGs or vector files, and here's the shape of our panel, and here's how we want everything, and she puts it all together for us, which has been really nice.
Yep, we do that as well.
I'm planning for when her student graduates. Like, what do we do next?
Buy one, man. It's not expensive, and it's really nice. We use my vinyl cutter to cut the numbers, and then we use heat transfer press to heat press them onto the bumpers. They never peel off. When you use a heat press, it gets right in the fibers, so it never peels off.
Cool.
I bought that again for personal projects myself, but we use it for the team, and yeah, it's really nice. In fact, we lettered our trailer with my vinyl cutter. So my vinyl cutter is 15 inches wide, and our trailer is vinyl that we did ourselves. We didn't have to pay it out, hire it out.
Sweet.
Okay, so any other kind of like, if you have the money, or if we ever were able to get the money, we would definitely buy this. I mean, what is it that next level competitive thing that you guys are interested in?
I got two things. We just bought one of them, a press brake that is made to fit into the bog standard Harbor Freight 20-ton shop press. So it's like, I think it's 18-inch wide, but it has enough beans to bend like 3/8 cold rolled steel. We're never going to use it for that, but it will bend. We've had a couple of times where we needed to tweak a motor mount. On our intake, the design was wrong, and we were caught out on not having a motor mount that was spaced correctly for the right size belt. And I was like, guys, we can just, get some aluminum sheet and bend it nice and tidily. And then, it's difficult to bend accurately without the right tools. If you're talking about getting belts to line up. But I found a company I can post it in the Slack or in the chat here, but it's a supplier for off-road, folks making mud and trucks and stuff. We got, as a part of a grant this year, we got a few $100 for this thing. And the thought being like, you can do the machining on some flat stock and then, score or mark the bend line and get that right where it needs to be in the press brake and make your own motor brackets is, it's like the stuff I've been trying to bring into the team this year has been prototyping acceleration tools, like how to fail faster.
That's a really good one. And so I bought one of these hydraulic presses for my own shop, and I haven't even used it yet. But my idea is that I could solid 3D print a mold and then I could bend in whatever shape I wanted, and I could
Yeah.
lay my flat stock aluminum that I would cut on my CNC in this mold, and then it would be able to push down into the V groove, whatever you call it, with the bending groove,
Yep.
or round stock, so you could do the negative and do the positive side of it and do a round or something like that. But now that I'm seeing this, I mean, even just on Amazon, doing a quick search here, these are not outrageous.
No,
And
I was kind of surprised.
Yeah, this is interesting.
Mm-hmm.
What's your second one?
I'm making something. I think that it looks like some of the FRC retailers are starting to do this as well. But when you're prototyping, like first week prototyping, and you're running stuff with drills, you're running your intake with a couple of cordless drills, or even the next stage when you're like, basically my goal is how to run motors without needing to tie up a program or take them away from the work that they're doing. And I've got 3/4 of it done. I might just go grab it. It's a control box that was running off of an Arduino Mega that's got a bunch of audio faders on it. They're actually flying faders, so they've got a little motor in them so they can move. And they are controlling a PWM output. Each one of them is controlling a PWM line, like a FRC standard, like the old school stuff, that you can on a Spark Max, on anything all of the major motor manufacturers will still take a PWM signal where you would otherwise give it a CAN signal. They can take either one. And then you have got a box that is software free, and you can control, this box in particular can control 4 motors. And the idea will be that you can, make some settings and then save a scene, and then make some other settings and save a scene, so that you can essentially like simulate your intake. You figured out what speed your intake wants to run at, or how fast to ramp up the motion of a subsystem, and then it will display those motor duty cycle values on a little 16x2 LED screen, so that you can say, "Hey, programmers, we tested this thing and it works great at 75%." So you've all of a sudden made a system where you're prototyping with the motors that you're going to use on the finished product, and doing useful intel gathering for the programming team to then program into their motion planning, putting it into the code, if you will.
Yeah, that's
and
super
me
cool.
plus a little bit of ChatGPT wrote all that code. So
that's funny, because ThreadUbot has their new Fusion, I forget what they called, the little motor controller plus PWM device, but they're expensive and they're out of stock, and it'd be great to have something that's off the shelf and easy to use. That sounds really cool.
Yeah, and I don't think this one will be that cheap either. I mean, these little flying faders themselves at quantity 1 are $25 a piece. I'm sure if I was to scale up, they'd be cheaper, but that's probably not happening this year. But I think I'm going to be testing it this year with our team, and if it takes, and if it's a real game changer, I'm going to try to make more of them.
So when you're using like the motors with that thing, how do you like attach it to like your prototypes? Because I know that the big draw with drills is you just put on like a hex adapter and you put on a churro or whatever, and just turn it.
Well, yeah, there's still a place for drills, even with the magical world that incorporates this box that I'm designing. The way you connect, you've got to power your motors independently, or you've got to feed them 12 volts from somewhere. And like in the case of, let's say we've got a couple of Neo 550s on an intake or something like that. The Neos are plugged into a Spark Max. The Spark Max is getting 12 volts through its 12 volt inputs, and then it's getting PWM signal through the CAN connector. And that's all it takes, right? Like all of the standard FRC motor controllers will just respond to a FRC, or I'm sorry, to a PWM signal, as long as it's within the spec of that signal, or the published signal. Yeah, did that answer your question?
What I was more curious about is like it seems from what you're saying that your prototypes come with the motors like literally attached to the prototype.
Oh, no. So let me see. Maybe I'm missing a step here. So we've made our quick and dirty drill prototype, and we're moving up to like a prototype that we are more confident in. Maybe we've got motors set in slots instead of in holes, right? So we've still got a prototype that we can sort of, it's malleable still. We haven't decided how much we're squishing the orange note down to the floor to pick it up, or how big the slot needs to be, or how fast we need to run these motors based on how fast the robot's moving, blah, blah, blah. We're at that stage, but we're still designing it, and the programmers have got better things to do, and we want to be able to make these motors spin without having to like fire up the code and have a controller and have a driver station laptop there. We just want to make the motors turn, and that's that is what this would essentially be.
Okay, yeah, that's a really interesting idea. I like that.
Yeah, and I'm going to make a lawnmower chassis to mount stuff to. I'm going to take. I've got it. Actually, I got this. I got to give credit where it's due to 2530. You make all your robots out of 80/20, and I want to do it too now because
we do. We
actually
do.
It's fantastic. So basically, you take you make a frame out of 80/20 instead of the drilled box tubing. I'm going to put some shopping cart casters on all four corners so you can treat it like a swerve, and then put essentially a lawnmower handle on it so you can drive it around.
That's
like if you want to practice
cool.
the floor,
but I have to tell you that your frame has to be 25 by 30, which we did last year.
I'll make sure we do that. So ease in prototyping, right? We're a team who competes first week, and the faster we can get a robot on the field, the faster we can turn a functioning robot over to our programmers and our drivers so they can make autos and so they can get familiar with its behavior, the better we're going to perform. We got high aspirations this year, so we got close last year.
All right. Well, we're running up on 8:30 here. Does anyone have any final pieces of advice or tips on tooling besides the vinyl? The vinyl is in the books. We got that recorded correctly. Vinyl in the books. All right. Well, then I'm going to put out another plea for teams to please sign up to host a topic. I'd really appreciate it if you would. Dr. B, I'm going to call you out. I'd love to hear about how your team is doing down there. I feel like you guys have got an amazing culture, and I get the impression, and maybe this is a false impression, but that you've recently had some transformative years and with students and the drive to compete or something like that. I feel like interesting things are happening in your neck of the woods, and I love if your team would have a get to know the inconceivables talk.
I'm trying to coerce the students to do that because honestly, yes, that's true. In 3 years, we've gone from like mediocre to okay to really good, and we want to be awesome. And it's about the CAD, it's about the scouting, it's about the programming, it's about the manufacturing, it's about all that stuff.
Sure.
So, we've had a lot of progress in all those things, and it'd be cool to talk about it because I've been a little part of it. I've been a little part, but there's a ton of people involved in all that.
Please tell your students I have a personal invitation to join us. And
we've got one student who happens to be my kid who has a fantastic presentation on like ecosystem of what you want to do for motors or gearboxes or like the things that are available to you from Andy Mark that you have to sort of choose, but depending on what your goal is, there are different options. So
sure,
I'm trying to twist his arm.
Selfishly, it always hurts me a little bit when I have to come up with a topic every week. So selfishly, I would like to ask anybody to sign up. But I love these get to know the teams, and I think Lily, you've been on here a ton. I love to have the Emperors on and talk about the team, and same with Millerbots. I think the Millerbots have also gotten a lot more exposure the last few years, and I think your culture is really great. I'd love to have you guys on and give a talk, and I really appreciate you guys joining the call week in and week out as well. So
We're doing our best
anyway,
to survive with very little resources and do our best to teach students how to win.
yeah, I don't think you're alone, but I think, how you're doing that is definitely going to be good advice, because we all scrabble a little bit differently. And so those tips and tricks are really great for everybody. All right. Well, with that, please, if you have anything that you want to chat about, even if you just want to kind of keep the conversation rolling, it doesn't need to be a presentation. Please sign up to host a conversation, or if you have a presentation you want to give 100%, let's do that too. With that, again, thank you for the conversation tonight, and I will see you all next week.
Thanks for hosting.
That's it for this week's FRC Roundtable. Join us live all season long, every Sunday night. Visit the website at team2052.com/roundtable to sign up for weekly invites. In the meantime, keep building, keep learning, and we'll see you next week.